All right, guys, so we are going to add to our notebook, but I wanted to share this with you first. So we did this hashtag activity a little bit ago, or maybe just a day ago. Yeah, just a day ago. And today what we need to talk about is these lines here are not parallel. How will I know, or when will I have enough information to know that they are parallel? And so we kind of played with this by moving these points around to get them to snap into place so that they will be parallel. Okay, so we're pretty close. And we don't have to go through this whole thing because you already did it, but like if we mess with this, hopefully what we noticed is that once we have a pair of congruent angles, oh dang, that's close, we can see that the lines will be parallel. So in this case, like these pair right here are trying to be corresponding. So if I make those corresponding angles exactly the same or congruent, I get that the lines are parallel. Now it doesn't have to just be corresponding angles, and here's what we'll kind of switch over to adding to our notes. If I have a certain type of angle pair and I know a thing about it, I might have enough information to say for sure that the lines are parallel. So let's actually go to here and add to our notebook now. So these ones I will post. So if you're at home, you can print them out. If not, I gave them to you in class, so you should have them now. They're not in our stapled packet. But we are going to add this on page 34. So on page 34, 33, we talked about when the lines are parallel, what happens. And when the lines are parallel, we have congruent angles or supplementary angles. So what we need to talk about now is how to know if lines are parallel. And that's going to be on 34. Okay, so how to know if lines are parallel. So we go here, we're going to take this one, just fold it in half like a book. And we're going to take this on 34. Okay, let me zoom in a little bit. Move that up there. Do a little zoom. Zoom, zoom. Okay. So when will lines be parallel? When do we have enough information to know for sure that the lines are in fact parallel? So if I'm given some information about some angle pairs, I may have enough information to know for sure that the lines are parallel. So we kind of talked about this already, like over here. If some of these angle pairs are congruent, then our lines will be parallel. So if I know that corresponding angles are congruent, then I know the lines are parallel. Or if I know that alternate interior angles are congruent, then I have enough information to say for sure that the lines will be parallel. Or if I know that alternate exterior angles are congruent, then I know for sure the lines are parallel. However, because vertical angles are always congruent, it doesn't matter if I have parallel lines or not. Vertical angles are never enough information. Like that will not ensure that your lines are parallel. Essentially, you just need two lines crossing to get vertical angles, and they're always congruent. So it won't ensure that that line below is at that same angle, making it parallel. So that's one way, and that's when these things are congruent. Or another way I can know it is if a certain pair are supplementary, then I'll know that the lines are parallel. And usually we just use same side interior here, but we could probably do same side exterior as well. So if I know that the same side interior angles are supplementary to each other, like I have to see that they add up to equal 180. It's not enough to know that they're different. It's not, well, I guess if they were congruent in both 90, but if they were congruent in not both 90, then we wouldn't have enough to know. Like they have to be supplementary, then the lines will be parallel. However, there is one pair of supplementary angles that won't ensure parallel lines, and that's linear pairs. Linear pairs are always supplementary. It doesn't matter if the lines are parallel or not. So that won't tell me enough information. Vertical angles and linear pairs are never enough information to tell me if the lines are parallel or not. Okay, so let's try a few. Open this guy up. So for these first ones, we want to identify if we have enough information to know that the lines are parallel or not. So which lines will be parallel if angle 1 is congruent to angle 2? So since we're talking about congruency, it's going to hopefully be one of those top 3 pairs. So if we take a look at angle 1 and angle 2, which lines will be parallel? So angle 1 and angle 2 are corresponding angles, and here's what I like to do to figure out which lines will be parallel. So angle 2 is touching this line here and that line there. Like that's kind of the 2 lines that form that angle. Now if I jump over to angle 1 is touching M and this line here. And once I've drawn all that in, you should have 2 lines and a transversal. The transversal is the one you touched twice. So 2 touched M and 1 touched M. M was touched twice. So that's your transversal. And that means that A and B might be your parallel lines. And since angle 1 and angle 2 are congruent and corresponding, then yes, the lines will be parallel, specifically lines A and B. So A will be parallel to B because angle 1 and angle 2 are congruent and corresponding. So you really have to say both. They have to be congruent and they have to be one of those pairs. So just like here, I have to be a pair and I have to be congruent. Then I know the lines are parallel. So it's like our if-then statements that we were talking about when we were doing proofs. Okay, so another one like that. And then this next one here, which lines will be parallel if angle 6 is congruent to angle 7? So if we take a look at 6, we take a look at 7. 7 is made up of line M and line B, because like those 2 lines cross and make angle 7 right here. Angle 6 is made up of line B, so I touched that one twice, and then line L. Okay, so once I kind of draw out the lines that make up the angles, because I touched this one twice, that is my transversal. And my potential parallel lines will be L and M. And they are parallel because 6 and 7 are congruent. They told me so, and they're corresponding. So L would be parallel to M because angle 6 and angle 7 are congruent and corresponding. Another way to kind of ask a similar question is down here. So if the measure of angle 5 is 65 degrees, so this guy here is 65 degrees, and then the measure of angle 6 is 115 degrees, are lines A and B parallel? So if we take a little look here, angle 5 is touching line A and line L, like that's how we make angle 5. And then angle 6 is touching line L and line B. So line L is our transversal because that's the one we touched twice. Are lines A and B parallel? Well, 5 and 6 are same side interior angles. And so if they add up to equal 180, if they're supplementary, then the line should be parallel because that's what's true here. So if same side interior angles are supplementary, I have a pair of same side interior. The question is, are they supplementary? So if I do 115 plus 65, is that 180? I don't think it is. Well, 6, 7. Oh, it is. Oh, good. 6, 7, 8. Yeah, carry the 1. 180. So yes, lines A and B will be parallel. So yes, A is parallel to B because angle 5 and angle 6 are same side interior angles and supplementary. They really need to be two things. They need to be a pair, and they need to do what that pair is supposed to do. So they need to be a pair and they need to be congruent, or they need to be a pair and they need to be supplementary. Okay, cool. So some algebra problems we can do with this are very similar to what we did in the previous little flippy book here. Basically, we look for a pair and we do what they're supposed to do. It just asks the question in a little bit of a different way. So what is the value for W for which C will be parallel to D? So what they're essentially saying is, I want C to be parallel to D. And so to make these lines parallel, I have to think about what needs to be true for this pair of angles here. So this pair right here is corresponding, and I need corresponding angles to be congruent or equal for the lines to be parallel. So I need to essentially do that. I need for these two angles to be equal. So I set them equal, I make them equal, because if they are, then the lines will be parallel. So then I solve for W to find that value that will make this angle down here also 55. So I add the 2. So 57 equals 3W. Divide the 3. And 3 will go into that because if I add up the digits, that's 12, so 19. So W needs to be 19 for these two angles to be the same, which will ensure your lines are parallel. So you're not really doing anything different than what we were doing previously. You're still making the angles either equal or supplementary depending on what type of pair. So similarly here, what is the value of X for which A will be parallel to B? So if I want A to be parallel to B, I need to think about what type of pair I have here and what that pair needs to do. So this is a pair of same side interior angles, and same side interior angles need to add up to equal 180. So we're going to do 111 plus 2x plus 9 equals 180. That's maybe same side interior, and then this was corresponding, just so we remember. And so same side interiors have to add up to equal 180 to ensure that the lines will be parallel. So that's what I do. I want to combine my like terms, so I'll have 120 plus 2x equals 180. Subtract the 120. So 2x equals 60, and so x would have to be 30. So x needs to be 30, because if I put in 30 here, then these two things will add up to equal 180, which will ensure that the lines are parallel. But really, you're just kind of doing what you had been doing. So hopefully it seems easy and not too strange or weird. And yeah, good luck.